So good evening, students. So myself, Navin Kumar. So destination as assistant professor. So the specializations will be the geotechnical engineering. So nothing but the soil mechanics and foundation engineering. Okay. So today class I will thoroughly go through the conceptual point of view. So again we'll study the first part will be the soil mechanics and second part will be the foundation engineering. So the first part, so regarding the geotechnical properties of the soil. So under that we have the index properties as well as the engineering properties. If you come into the foundation engineering, so once if you know the soil properties, so we have to design for the given subsoil properties what is the suitable the bearing capacity values, and also what is the pressure is exerted behind the retaining walls, and what will be the stability of the slopes of the factor of safety, right? So we can found it in the foundation engineering chapter. Okay, so here, okay, so I will go through the conceptual point of view, right? So now you can observe. So when you say the soil mechanics, so we have to deals with the soil. So under the principle of the engineering mechanics, then the fluid mechanics, and if you know the laws of the hydraulics. So what should be the flow of water below the ground, like that. We have to apply the principle of both the engineering mechanics, then the fluid mechanics. Okay, these are all the engineering point of view for soil. So the soil mechanics first with the coined by the engineer, the Carl von Terzaghi. So he was considered as the father of soil mechanics. Okay, so according to his statement, so what we call it as the soil. Okay, so soil we can call it as the all the three terms based on the engineering point of view. So based on their agricultural point of view and based on their geological point of view. Okay, so when you say the soil, it should be the unconsolidated materials which lies above the earth crust. Okay, so with how should be the loosely bounded. Okay, so when you say loosely bounded, nothing but we have the individual soil particles like that. Okay, so now you can observe when is a loose mantle at the surface of the earth which favors the growth of the plant. When you say the favors the growth of the plant, so the statement according to the agriculture point of view. Okay, so we want the engineering purpose. So when you say engineering purpose, we deals with the application of the principles, right? So it is a natural aggregate of the mineral grains, loose or moderately the cohesive or inorganic or the organic in nature. So when you say the engineering point of view, we deals all with respect to the minerals, the grains, the individual particles, what is the minerals content. If you take for a purely sandy soil, it consists of the quartz or it may be the feldspar. If you take the cohesive soil, maybe the black cotton soil, it contains the clay forming minerals like kyanite, illite, monticulite. So these are all what we call as the minerals, right? So based on their minerals, we can expect the different specific gravity, right? Then is the disintegrated rocks. According to the geologist, the soil can be defined as the disintegrated. Okay, so can you observe according to the engineering point of view? So we can classify the soil into the option B. Okay, the option 1 regarding the agricultural point of view, then option C is regarding the geological point of view, right? We want the engineering point of view, so is regarding the natural aggregate of the mineral grains, the loose or the moderately the cohesive, or it may be the organic nature, so that we can say this for this correct option will be the option C. Okay, okay, so the next one. So when we know the soil term, so we should know how the soil can forms. Okay, so it can be formed by the two methods, either by the physical methods or it may be the chemical methods. Okay, so when you say physical methods, commonly we call it as the weathering terms, right? So what may be the weathering terms, right? So due to the heavy temperature, so when the temperature is subjected to the rock, right? So due to the heavy temperature, these rock get disintegrates. The periodically temperature variations alternate the freezing and thawing and temperature rising. Okay, then so what is the action of the flow of water? Okay, so during the movement of the water through the soil, it always creates the spaces in between the soil particle that should away with the fines. Okay, so then the splitting action of the ice. So if you take the glacier soils, so in the mountainous soils, so we have the mountains, in that we have the covered with the ice, right? So again, due to the action of the due to your freezing and thawing, what happened? The ice get the disintegrates in the form of the splittings in the form of the wedge shapes. Okay, so then abrasions. Abrasion nothing but your rubber actions. So due to the movement of the soil particles, right? So what happened? The particle to particle get abrasion. They forms. So starting from this angular shape to the subangular to the subrounded, like that we have the various terms due to the weathering actions, right? So that we can say when you say mechanical, we should require the additional the parameters to form the soil, right? So when you say on the soil something but to formation of the soil, so the first option will be the temperature we require, it forms the weather. The second one, the splitting action of the flowing water, the flowing action of the water, and third one, the splitting action of the ice, right, in the mountainous regions. Then if you take the soil particle, so particle to particle, they will have the abrasion so that they will get the breakdown, so that we can say mechanical weathering tends to this all the I think. But when you say the soil get weathers, it requires additional the parameters. Okay, so this answer will be regarding the your all of the above. Okay, it requires the seasonal temperature variations, the splitting action of the flowing of water, then the splitting action of the ice, then abrasion. Like these are what we call as the mechanical weatherings, right? So when we coming to the chemical part, right? So when you say the chemical part, okay. So when you say the chemicals, right? So previously we discussed about how the soil forms due to the weathering actions, right? So next one, if you take the fine grained soils, so in the form of the soil having certain the plasticity characteristics, okay. So in the due to the presence of the mineral properties, right? So it requires due to the oxidation process, right? When we have the soil reacts with the oxygen, then again we have the hydration reacts with the water, then the hydrogen, then we have the carbonations and leaching and the hydrolysis, right? So this soil can be formed in all the four options: the oxidation, then carbonation, leaching, and the hydration, right? So these are all comes under the hydration, or it may be the chemical weathering of the rock, or it may be the soil, right? Therefore, this option again goes to the your all of the above, right? The soil can be formed, can be both the mechanical as well as the your chemical part. Okay, so due to the chemical part, so we have the oxidation part, then hydration part, then carbonation, leaching, and the hydrolysis part. Okay, so when we have the soil reacts with the oxygen and the hydrogen, like that, we have the certain process to formation of the soil. It reacts with the carbon hydroxide and sodium hydroxide, like that. We will have the chemicals. It will form the certain the residues that we call the soil fractions. Due to this presence of, it forms certain the plasticity characteristics. It form the clay minerals like that. Okay, so then if you're coming to the how the soil can be formed due to the weathering actions, right? So we know that the mechanical weathering comes under the rubbing action, the abrasion, or it may be the seasonal variation of the temperature, or it may be the splitting action of the ice, or it may be the flowing of water through the interconnecting voids, right? So when the weathering occurs, so what is the formations? Okay, so we have the soil. Okay, so first when you say weather, the soil get transported, right? The first geological cycle will be the transportation. Then what happens due to the transportation? It will get the deposited. Again, it will get the uphill. Again, get the weathering portions like that. Okay. The first option will be the first cycle. Can observe here. They pick up the correct sequence of the geological cycle of the formation of the soil. Right. The first always will be the comes to the your. So what happens? The soil we have. Okay, so here the soil particle we have with the residue in the certain places. Okay, so what is the first geological process? Okay, so we have the one place soil. Okay, so it should be get weathered. Okay, the soil get weathered. It should be due to the action of the physical, it may be the chemical action. The first sequence will be the weathering part. Okay, so once we get weathers, what happens? It will be moves, nothing but will be the transportation. The second portion will be the transportation part, right? So once you get the movement, so what happens? Again, get the deposited in the downstream sides. Okay, this is the deposited in the formation of the downstream side, like the mountainous regions. Okay, so then once you get the deposit, what happens due to the wind actions? Okay, right? So what happens? Again, get the uphills. So right. So the first sequence will be the soil get weathers, then get transported, again get deposited, again get uphill, nothing but deformation of the hilly regions like that. So we have the fourth option will be your correct sequence of the geological formation of the soil. Okay, so whatever the soil property, so get weathers, then transported, then deposited, then get uphills. Uphills nothing but it's the formation of the upstream like that. This is the up portions. So we have the upstream, right, with the hilly portions like that, what we call as the uphill portions. Okay. The correct sequence will be the option D. Okay, so as we know that in the previous we discussed how the soil get weathers, the physical action, the chemical action, and what is the geological formation. What is the sequences of the geological formation? Okay, so next one. So once the soil get weathers, so we can classify it into the basically two categories. Okay, so the classifier we can call it as the first one will be the residual soils, and second will be the transported soils, right? So if we call the residual soils, right, the residue nothing but so their formations. Okay, so when we have the rocks in the form of the metamorphism, it may be the sedimentary dimorphism, it may be the igneous rocks, right? Suppose if you take the igneous rocks, I'm taking the basalt rock. So in this basalt lag, so due to the aging of the rocks, the soil get leaching out. It will do the formation of your chemical action. It may be the chemical process, maybe the carbonation, the hydrolysis, it may be the hydration, it may be the your oxidation like that. We have the various process due to the aging of the soil, it will get deteriorates to the part, right? So again to get the deteriorates, right, the residue at the certain portion of the soil particle and will be remain at the place of their parent rock, right? So that we call as the residual soils, right? So whatever the soils, we have the gravelly type of soils, then sandy type of soils, then silt and clay. So these are all comes under the residual soils. Okay, so residue nothing but it remains the place as it is, right? If the move towards the other place due to the transporting agents in the form of the water, or it may be the air, or it may be the gravity, or it may be the lake formation, lake or running water and the stagnation water like that, we have the transporting agents, right? So here if the soil particles were remain in the place of their origin, we call it as the residual soils. For example, if you take about the general, the gravel, sand, silt and clay soils. Okay, so then so when the products of the rock weathering are not transported, right? When you say not transported, nothing but it remains at the place of their origin. So we call it as the residual soils. Then what will be the alluvial soils, eolian soils, and the colluvial soils? So these are all comes under your the transported soils. Okay, they transported it, right? So then we have the certain classifications based on their transporting agency. It may be the wind, water, lake, then glaze, ice like that, and we have the gravity soils like that. We have the various transporting agency. We have the certain notations. Okay, so when it comes to the notations, so can you observe here? So we have the part will be okay. So can you observe here? We have the various the transporting agency, right? So here these are all the soils we called as the So transported soils. These are basically we can classify in two categories. The first one, the residual soils, and the transported. Okay. So here the transported, the first soil we called as the alluvial soils. Right. So when you say alluvial soils, so we have the river. So during the moment of the heavy floods or any the movement of the water, what happens? It will flow. So along with the flow of water, it will take the certain sediments. Okay, the sediments will be take care that it will have the rich in good, right? Maybe the iron, the content, or it may be the alumina content. We have the very quite helpful for the growth of the plant. Like that, we have the alluvial soils, nothing but so the river over the running water, the formations we call as the alluvial soils. Okay, so then if you take the sea water, right? Again, when say marine soils, nothing but the sea water, we call it the marine soils. When you say the lacustrine soils, the first letter indicates about lake, right? The soils are formed, so below the lake, we call it as the lacustrine soils. When the water is still water in the lake or it may be the pond, we call it as the lacustrine soils. Then if you take for the wind actions, okay, again due to the formation of geological stratum, we have the first weathering, the transported, then sediment, then uphill, right? So during the transported, we have the action of maybe the wind actions, right? During the wind during the desert soils, right? So in the desert soils, we called as the aeolian soils or maybe the air soils or aeolian soils. For example, if you take for a sand dunes, or it may be the loess, right? So when you say sand dunes, it having completely uniformly graded soils, right? All the particle will have the same size. We call it as the uniformly graded soils. These are the wind blown soils, right? If you take the loose, so loose soils, nothing but LOESS soils, nothing but so it consists of the equal proportions of the sand, silt, and clay. So we call it as the loose soils, right? It contains the equal proportions of all the sand, silt, and clay. We call it as the loose soils, right? Then if you take for the glaciers, nothing but ice, right? The ice, the common term notation as the till or the drift. Okay, so these are the soil formation formed by the ice formations. The ice till or drift, nothing but the ice formation. This soil is what we call as the glacial soils. Right? So during the landslide occurs, so what happens? It will be the soil get deposited freshly. That we call as due to the action of the gravity or the landslide. So we call as the colluvial soils, or it may be the talus. Okay. So in normally typically they given all the soil classification regarding about the transported soils. Okay. So here the residual soils is conventional your sand, gravel, silt, and clay. Okay. When you say the transported, we have the transporting agency in the form of the water, wind, right? Then you can observe here we have the marine water, then sea water, it may be the lake water, or it may be your pond, right? Then we have the wind action, then the ice or glaciers, or it may be the gravity, or it may be the colluvial soils. Okay, so these are all around the four classification comes under the transported soils. Okay, so now you can observe here based on this category. So we have to classify the soil, what it means exactly. Okay, so we know that so residual soils, nothing but as we previously discussed, we have the gravel, sand, silt, and clay. Nothing but in the soil mechanics, we deals with only the residual properties, right? What is their minerals, what is their specific gravity, what is their grain size, and what is their plasticity characteristics, and what is their density, and what is the strength of the soil regarding the compaction, the consolidation, the shear strength, and permeability. We deals with only the residual part. Residual soils only, not transported soils. Okay, so this is over here for this condition. The residual soils, it includes gravel, sand, silt, clay, nothing but all of the above, right? So for this condition, we can say the option will be the option E, right? The residual soils will be all the four, starting from the gravel size to clay size. Okay, So next one. So we have the cohesion-less soils. Okay. So when you say the cohesion, right, we should understand the difference between the cohesion, the adhesion, and cohesion-less, like that, right? So when we have the cohesion, nothing but, so when we have the molecular force, so molecular force, nothing but, so we have the one molecule, and we have the same attraction, the attraction between the same molecular force, right? So that we call it as the cohesion values, right? So suppose if you take for having about the pile material, right? So pile, nothing but we have the long, the slenderness column. Okay, so we have the point edge, and this will be the pile cap, which rest on a certain soil to resist the loads were coming on the superstructures. Right, this is the resistance loads we have to complete resistance. Okay, now we can observe here we have the different materials. Here we have the soil. Okay, so here we have the pile materials. It may be your composite materials. It may be the concrete. Or it may be the iron piles. Or it may be the composite thing. But the certain portion of the pile metal may be the above portion will be the about your the steel, and below will be the concrete. Like that, we have the two different materials we call as the composite. Right. So for this condition, so we have the pile as well as the soil, we have the two different materials, right? When we have the two different materials and attraction, what we call as the adhesion part. Okay, so when you say the cohesion, nothing but the attraction between the same particles, nothing but the soil to soil, we call as the attraction will be the cohesion, right? The soil to the pile material, that we call as the your adhesion part. Okay, so here the soil particle to soil particle, there is no attraction, that we call as the cohesionless soils. There is no attraction between the same molecules of the soil. If you take for the gravelly soils, okay, it may be the sandy soils, it will be the particle, there is no attraction, they'll be having only the friction values. Okay, so in this condition, so we have the cohesionless soils, nothing but only the sandy soils, because when we have the silt as well as the clay, it always possesses some the plasticity characteristics. When you say plasticity, there should be the cohesion values. Okay, so for this condition, we can say the cohesionless soils for an example of the sands, or it may be the gravelly soils, right? The remaining, the silt and as well as the clay soils, which comes under the cohesive soils. Okay. Okay, so next one we called as the silty soils. One we called as the certain, the gravelly soils, the silty soils, then sandy soils and clay soils, right? This would be the difference. The silt can be defined, right? So we know that if you say the defined in the form of the about grain size, okay? So the particle size, it always starting from the larger size particle, gravel, then sand, then silt and clay. Okay, so if you take for the silty soil, so we have the size of around 75 micron to 2 micron. So this is regarding the diameter of the particle size, right? If the particle size work comes in between the 75 micron to 2 micron, we call it as the silty soils. Okay, so when you call it as the silty soils, right? So we have the options. The option one, the material is deposited by the glaciers, right? So when you say glaciers, already we discussed, this is completely a transported soils, right? So we know that the silt, clay, gravel, sand, which comes under the residual soils. Okay, when you say the glaciers, nothing but the ice below that, the formation of the soil, we call it as about the drift. Okay, so drift and the till soils, right? So this is the formation of the your ice. This all comes under the transported soils. Okay. The second one, the soil is composed of two different materials, right? The certain portion of the soil may be the bigger size particle, the coarser particle, and some of the particles possess some the sort of the cohesion values that we call as the plasticity characteristics, right? So this will becomes under the dual combinations. Okay, so when you say dual combinations, okay, so the first one regarding the size of the particle and second one regarding their plasticity characteristics. Okay, so for example, if you take for about so clay, gravelly soils. Okay, so these are all what we call as the soil composite of two different materials, right? It contains both the characteristics of the gravelly soil as well as the clay soils. Okay, the next one, the option 3, the fine grained soil with little or no plasticity. Okay, so when you say fine grained soils, nothing but whatever the particle size were less than 75 micron, less than 75 micron size, we call it as the fine grained soils. Okay, so above 75 micron, we call it as the coarse grained soils. Okay, so we know that silt is always comes under the fine grained soils, which have in the range of 75 micron to 2 micron size. Okay, it having the certain plasticity characteristics, right? So due to the about the complete residual soils, it have the certain the plasticity. Okay, it is the fine grained soil. This option is correct because which comes under the grain size of 75 micron to 2 microns. Then which have the a little or the no plasticity. Okay, if you take for the soil, the sandy soil as well as the silty soil, it almost look like sand, right? So only we can categorize. So based on their plasticity, if the soils were possess a little amount of the plasticity, we call it as the silty soil. If not, we call it as the sandy size. Or also we can determine based on the grain size. Okay, if the particle size were less than 75 micron to 2 micron, we call it as the silty soils. If the particle size were more than 75 micron and but less than 4.75, we call it as the sandy soils. Okay, so we can decide based on their two categories, based on their grain size as well as the plasticity characteristics. Next one, the clay with the high percentage of the clay mineral, this will comes under the clay soils. Okay, so due to the presence of the montmorillonite, the kyanite, illite minerals, that we call as the clay soils. Okay, so here the option will becomes under the option 3. Okay, the first regarding the deposited soils, the till or the drift soils, it is the formation of the glaciers or the ice formation. The second one, it is the comes under the dual combination, right? The silt is given only one value. Here we not get the silty soils. We preferably only about single the soil classification. And next fourth one, if it comes to the clay soils, which containing a montmorillonite clay mineral, we have the high percentage of the swelling characteristics or to be the shrinkage characteristics, right? Therefore, this option will becomes under option 3. Okay, now you can observe the black cotton soil, right? So when we have the black cotton soil, for example of clay, right? So what is the size of the clay? So we have the 75 micron to 2 micron, we have the silty soil. Then less than 2 micron will be your clay soils. Less than 2 micron of size of the particles, we call as the clay soils. Under that, if you take the black cotton soil is completely the residual soils, right? It's formed by the disintegration of the igneous rocks like basalt. The leaching process by the action of your chemical process with the leaching formation, we can expect the soil particle will be disintegrated like individual particle in the formation of around less than 2 microns. Okay, so when you say the clay soils, it can be both the completely the inorganic soils without carbon, right? So we have the inorganic soils in nature, and it contains the large percentage of the clay minerals. It may be the montmorillonite clay mineral, it may be the kyanite, illite, or the spectrite, or the halloysite. Like that, we have the different the clay forming minerals. We have the particle size. Okay, so and also it exhibits the high compressibility, high shrinkage, and the black cotton soil. Okay, then it is a chemically weathered residual. So as we know that when you say the igneous rocks under that basalt, the formation of the black cotton soil itself will be by the action of the leaching process. It's completely the chemical interaction, so that we can say it comes under all the options. Okay, the black cotton soil, nothing but we have the grain size of less than 2 micron. It is completely inorganic soils. There is no carbon in it. If you burn it, there is no smoke is produced, that we call as the inorganic soils. Then it expects in the form of the large amount of the the clay minerals. The units of the presence of the clay minerals, it always expect the swelling and the shrinkage properties of this soil, right? Using the black cotton soil, you have seen in the earth. So in that, you always expect the swelling and shrinkage characteristics during the rainy as well as the summer seasons, right? Due to the presence of the clay minerals, right? So it should be the chemically weathered soil. So that we can say the black cotton soil will be the option E, right? All the conditions were satisfied in the black cotton soils. So next, when you say the organic soils, right? So in the previous, we differed about the inorganic nature, and here we can discuss the organic nature. When you say organic nature, and we should have the certain, the decayed matter. It may be the any waste, the dead roots, or it may be the animal decay, that we call as the organic matters, right? So when you say the organic matter, it we call as the some part of the soil, the humus soil, or it may be the peat soil, right? So when you say peat soil, it is an example of the organic soils, right? The inorganic will be we call as the either silt or the clay soils. We call it as the inorganic soils. The organic soils which comes under about the peaty soils, or it may be the humus soils. Okay, the humus nothing but on the soil we have a certain moisture in it that we call it the humus in nature. Okay, so here the peat is a composite of the decayed vegetable matters. Okay, the decayed vegetable matters that may be the animal decay, that we example of the peat. Okay, then what is the clay and sand will be comes under about the inorganic soils, right? So then the inorganic silt and clay again, which comes under then synthetic chemicals. We don't get any the peat formation due to their synthetic chemicals, right? The peat nothing but it always the organic in nature. It should be formed by the action of the animal decay with the dead roots. Okay? Therefore, the option will be the B. So decayed vegetable matters. Okay, next one here. So we have the humus soils. Humus nothing but we have the soil. So on the top of it, we have a certain moisture level that we call as a combination of the soil plus the water content. Like that, we have the type of the rock, then inorganic soils, then the fully deposited soil, or it may be the half deposited soil. Nothing but we have the soil, and that we have a certain moisture. We call it the half, right, deposited. Therefore, the option will be the even half deposited soils. It cannot be fully deposited soils. When you say fully deposited, again we can comes under the inorganic, or it may be the organic soils. Okay, then inorganic, it may be the silt or it may be the clay soils. The type of the rock, again we have the based on their geological formation of the rocks, we have the igneous metamorphism, that may be the sedimentary rocks, right? If you take for igneous, your granite, the basalt, like that. So what are the formation of your metamorphism? Nothing but due to the action of the temperature and the pressure variations. You are the carbonate, the calcium carbonate, like that. You are the roof tiles, with the floor tiles. This all comes under the sedimentary part, metamorphism, like that, right? So for this humus, they are always of deposited soils. Okay, next. So as we know that loam, so loam, it is a sandy clay with little silt, sandy clay with little sand, silt, clay, and gravel, and sand, silt, and gravel, right? When you say loam soils, loam nothing but we have all the proportions, right? So when you say all the proportions, nothing but, so we should be having the combination of, here can you observe the loam soils, which always comes under the classification regarding both the contains the well-graded type of soils. It contains all the particle ranging. So starting from sand, silt, and clay, right? So here we have the option C, the loam soils, nothing but. So we can preferably observe in the form of the triangular, the textural classification system. We have the sand, silt, and clay, like that. So if you just meet the exact middle points, which will be meet at exactly center will be the loamy soil. Nothing but if we have the equal proportions of the soil. When you say equal proportions, we have the total about 100%, right? So we have the triangular, the textural part, and this will be the, we can say, sandy soil, and this will be the clay, and this will be silty soils. This all comes under the triangular, the classification of the soil. Okay, so in that the loamy soil which comes under is exactly at the middle point, because if you take the equal proportions, right? If you take this about the equal proportion, again the clay equal proportion and silt equal proportion, the central part will be the classification comes under the loamy soils. Loamy soils nothing but it is the equal proportion of these sand, silt and clay soils. Okay. The next one, the warwood clay. So these are all comes under the transported agency in the form of the flowing of water, right? So when you say warwood clay, it should be the, so we have the deposition. So deposition in the made up of, right, the running water. It will be made about the thin layers. The first layer is one material, the second layer is another material, and third layer is one more materials. So like that we have the various the soil layers. Okay, if the layers were formed in alternate conditions, in an alternate condition of the silt, clay, then again the silt and clay, the formation of the alternate layers. Okay, so it's like your cake, right? We have the different layers in that. For how, if we have the layers in an equal proportion of the thin layers of the alternate layers of the silt and clay, so we call it as the warwood clay. Okay, the warwood clay nothing but it is the alternate layers of the silt and clay. Okay, therefore this option comes under the option C, the alternate layers of the silt and clay. Okay, so when we have the mixture of the sand, silt and clay, right? So when you say we have the sand, silt and clay, we call it about in the previous slide about loamy soils. Okay, the loam, it is the equal proportions of the sand, silt and clay soils. Then we have the chemically bounded the soil mixture. When we have the black cotton soil, it should be formation of the chemicals, right? This will be comes under about the black cotton soil, or it may be the expansive soil. Okay, it may be called as the clay soils. Okay, then we have the decomposed volcanic ash, right? So this also comes under the black cotton the soil. Okay, we have the high plasticity soils with the formation of the your. So when we have the earth crust and the formation of the lava which comes under the out of the cloud, but that comes in the ground surface, we call it as the volcanic. So in the decomposition of the volcanic, we have the high percentage of the clay minerals in the form of the swelling and the shrinkage properties. Okay, so for this condition, warwood clay nothing but it is the alternate layers of silt and clay. Then, so we have the fine grained soils. Okay, so coarse grained soils nothing but we have the size of above 75 micron, we call as the coarse grained soils, and below 75 micron, we call as the fine grained soils. Okay, so when we have the fine grained soils, okay, so we can observe we have the soil particles will be very less, which can be easily identified by the microscopic, the individual soil particles. Okay, this is the fine grained soils. Fine grained soil nothing but the particle size were less than 75 micron, we call it as the fine grained soils. So can observe when we have the fine grained soil, the option one we have the low permeability, right? So what is meant by low permeability? So permeable nothing but, so we have the movement. Okay, ability nothing but we have the ability, right? So the permeability nothing but we have the ability to move along their voids. right? So can observe we have the particle size will be very low, and we have the voids will be like that. So when we have the just pour the water here, the inflow water, so what happens due to we have the heavy void spaces, okay, and we have the numerous the soil solids we have abstract. So the movement of the water, what happens, it will be like that, it will take the longer path due to their voids, okay. So we'll have the low permeability, nothing but due to the movement of the water it will takes very low, right? If you take the sandy soil particle, we have the notable the grain size particle. So we have the bigger size particle. So like that we have the voids, okay. So this is the voids will be we have. This is the coarse grained soil particle. When we have the water, so can observe we have the easily we can pass it. It will have the highly permeable soils for a coarse grained soils. Okay. So for a fine grained soil, nothing but the path traced by the fluid particle, it takes a longer time, that we call as the low permeable soils. It can matches. Okay. Okay. So then the second option will be have the high compressibility. Okay. So when we have the black cotton soil, as we know that due to the plasticity in nature, this soil can be compressible. It will take the higher loads and the lesser load to compress the particular depth. Okay. So if you take the certain load and you can observe certain deformations, you can observe very minor for a coarse grained soils, whereas the same pressure is applied on the clay type of soils, which can expect the heavy deformations. Okay. So the second options it also matches. Okay. The third option, it may or may not be plastic. As we know that the fine grained soils, it may be the silt as well as the clay soils. As we know that the clay is perfectly, we have the plasticity. If there is no plasticity, we call it as the sandy soils. There is no plastic, even if it is about less than 2 microns, right? If the soil possesses the plasticity, then only we call it as the clay. If not, we call it as the sandy soils. Even some of the soil particle may possess the little or the no plasticity, we call it as the silty soils. Both the clay as well as the silt, which comes under about the fine grained soils. Okay. Therefore, this also matches. Therefore, the condition will be for this fine grained soils, all the properties get matched, so that your answer will be the all of the above. Okay. Okay. As we know that, so based on the transported agency, by the action of water, wind, then lake, then sea water, then the gravity, then glaciers, we have the certain notations like that, right? As we just discussed, the soil transported by the wind action, we call as the evolving soils. Okay, air evolving soils. So then alluvial soils, it is transported by the action of water, other the running water. Then marine soils, the sea water depositions. Then lacustrine soils, it is the lake deposit, I mean the still water depositions. Then, as we know that, so can you observe we have the physical, the mechanical weathering process. As we know that the mechanical weathering process will be the temperature changes. Okay, so then we have the rock. So probably in the mountainous regions or the hilly area, we know that in between the rocks, if you have that tree, so due to the spreading of water, this spreading of roots over the period of time, the rock get disintegrates. This is all the action of by the physical formation, by the mechanical of weathering of rocks. Okay. The next one, the wedging action, then the abrasion, then all of the. Alright. Is all the options work comes under the mechanical, the weathering of rocks. Okay. So here, the which of the following is incorrect, the process of the physical action, right? Incorrect, nothing but we have to choose the wrong options, right? So can observe here the wedding, the incorrect. the physical disintegration of regards the formation of the soil. Okay, okay. So we know that. So the presence of the organic matter in a soil makes it the swell at lowest moisture content, the spongy in nature, the shrink with the increasing moisture content, and none of the above, right? So when we have the organic matter like PT soils, okay. So for the PT soils, what will happens? We have the both inorganic as well as the organic soils. Okay. So in the inorganic soil, the organic soils, it makes the both the completely the spongy natures. Okay. So therefore, this comes under the option B. So when we have the slow swell at low moisture content, so even if we have only the clay forming minerals, the black cotton soils, and that we have the montmorillonite clay or spectate or alizate clay forming minerals, only swell at the low moisture content. This is completely inorganic soils, not organic. Okay. Then shrink with the increasing moisture content. If you take for about the your core reasons, we have the coil soil called as the collapsible soils, right? So in the collapsible soils, with the have the water content, if you just increase the all the get soil get collapse, right? The collapsible soils, maybe the expansive soils, completely opposite in nature. When we have the blackened soil, if you just increase the water content, the soil get fills. It will be the expansive soil. Then if we have the collapsible soils, if you just increase the water content, the soil gets shrinks. That is the example of the collapsible soils, right? So this is regarding the swell at low moisture content will be the expansive soil. Expansive soil. Then the shrink with the increasing moisture content regarding the collapsible soils. Okay. So these are all comes under the two with the increasing water content and decreasing the water content regarding the volume expansions. Okay. So can you observe here we have the loose term when we have the soil classification regarding the wind action, right? This is completely transported soils under the action of the air. The air blown soils, or it may be the air soils, the loose soils, indicate those soils which are uniformly graded soils, then poorly graded soils. So made up of 50% or more size particles, then made up of more than 50% of the silt particles. Which of the statements are correct? Okay. So when you say the wind blown soils, it always comes under the uniformity of soils, right? If you have the classification, the particle size distribution regarding the coarse grained soil, if you simple test regarding the sieve analysis, if you take the loose soil and we just kept on the sieve and shake it for about 5 minutes, and after that we take the sieve and weigh it in the weighing balance and we just note down. So we'll have the uniformity of the soils. Nothing but all the particle size will not get. Only the particular range, the uniformity, nothing but if you take the particle about the 2 millimeters to it's around 1 millimeter size. In all different percentage finds we can expect. Okay, the same particle size, the same range of the particle size we have in all the different percentage finds, right? For the 10 percentage finds, we can expect the same diameter, then 30 percentage, 50 percentage, and 60% of the finds, we always expect the same values. This will be called as the uniformity coefficient, right? So once you get the uniformity coefficient, if you just compare the ratio, it always goes to unity. That will be the uniformity of soils, right? As we know that the wind-blown soils always comes under the uniformity of the soils. It will becomes under always the straight line or the perfect, the single, the I-shaped line. Okay, so this also is satisfies, right? Second one, it is poorly graded soils, right? So when you say poorly graded soils, nothing but what is meant by that? So we have the gradation criteria, right? So when we have the gradation criteria, nothing but the certain values. So we will discuss in the next unit the index property of soils. Into that, we have the terms CU and CC terms to classify the soil. So based on their quality. When you say quality, we have the either well graded or it may be the poorly graded soils. To decide that, the symbol W or P, we should require the coefficient of uniformity and the curvature coefficient. Okay. So for this condition, we know that it is poorly graded soils. Okay, we have the condition. Then made up of the 50% over the more size particles, right? So when we have the percentage of the particles for more than that, we call it as about not the single grain, should be the well graded soils. We can't call it as about the well graded soils. And it is made up of the more than 50% of the silt particles, right? So what is meant by the silt particles? It may be the size starting from the 75 micron to 2 micron, that is the silt range. Again, we know that we have the same, so 2 micron to the particle size were the 75 microns. Again, we'll have the made up of 50% as overall the more than the silt particles will comes under the again the single lines, because the same particles were silt, which comes under only 75 micron to 2 microns. So can observe here. So based on this condition, which of the statements are correct? We can observe which can be matches with respect to the first, second, and the fourth one. However, we have the option is preferably 1 and 3, 1 and 4, 2 and 3, and 2 and 4. Now we can judge these two factors, right? So when we have the poorly graded soils and the uniformity, right? So wind blown soils, it always comes under the uniformity soils. Only uniformity of the soil particle will be comes under, so that it is always preferred about the option 1. Okay. So then regarding the 4, so we can say option 1 and 4, nothing but it is the option B. Okay. Second, so here you can observe we have the terms. So consider the following effects as indicating of the complete saturation of the soil sample. So we should know, so when we have the soil sample, it contains based on the inorganic properties in the form of the solids. And then we have the voids, that will be the voids, it may be filled up with air or it may be the water, that we call it the phase system. Okay. So in the saturation of the soil sample, so here we have the soil particle. Okay. So here we have the soil particle. The symbol red indicates your soil grains. Okay. So in between we have a certain moisture. Okay. So here some of the space is filled with the air content. So here this term will be the solids, and this will be the space is filled up with the certain moisture content will be the water, and the gap will be the your air portions. So can you observe we can easily measure the gravimetric as well as the volumetric terms in the form of the solids. Okay, this will be the solid portions. We call it as the volumetric will be the volume of solids, and corresponding the quantitative analysis of the volume of the water present in the voids, this will be the VW, and volume of air will be VA. Okay, so for given the volume of the air, water as well as the solids, we can take the constant value will be the solid portions, because for the solid portions we should know what is their weight of the solids and what should be their volume of the solids. Okay, so this will be the fundamental, the predetermined value, so that we can take test the volume of the solids will be as your reference. Okay, so only the variable term will be your either air or it may be the water. Okay, so during the rainy seasons, the entire voids is filled up with the water content voids. During the summer season, the entire voids is filled up with the air content. Okay, so only the variable term will be the your voids, so that the combination of air plus water will be the your void spaces, nothing but. So here the voids nothing but it is the combination of air plus water. So here, so we have to define the certain terms will be the saturations. Saturation nothing but, so in between the voids, what should be the amount of water in the form of the quantity, we can call it as in the form of the volume terms. Okay, so degree of saturation can be defined as, so we have the major proportions will be total volume. Under that we taken as the solids as constant. So in the voids, okay, so in the voids, what is the water? Okay, so how much amount of the water present in the void spaces we can express in the form of the percentage. This will be the saturations. Okay, so here for complete saturation nothing but the entire voids is filled up with water. Okay, so here we know that for this condition all the spaces are filled up with the water. Here we have the soil particle, so entire the void spaces will fill up with the water, and this will be the soil particles, this will be the spaces. Now can you observe we have the entire voids is filled up with water, so VV is replaced by VW, so that so VW get cancelled, so that the saturation goes to 100%. This will be the your fully saturation, it will be the complete saturation. For this complete saturation of the soil sample, the voids is filled up with water, we call it as the saturation, right? So for this condition, the statement 1, the pore water pressure is positive. What is meant by pore water pressure? So we have the certain the ground profile like that. Okay, so below that we have the natural water table at a certain depth below that, and we are interested to measure the pressure at a particular depth below the ground level. I want at this depth what should be the pore water pressures, right? So to get the pore water pressure, we should know what is there this the quantity of the water in the form of the certain the heads of the water, and we should know what is there the unit weight of the waters, right? So we should know what is the unit weight of the water. It should be always gamma for water. Okay, so for water we should always take the density of the water should be at 27 degrees Celsius, we taken as 1 gram per cubic centimeters. If you want to express in the form of the SI system, it should be around 10 kilonewton per meter cube. Or if you want a precise value, we want gamma, and if you know the rho value and the gravity value, rho is 1, the gravity of the earth is 9.81, so that we can say gamma is equal to 9.81 kilonewton per meter cubes. So this is the unit weight of the waters, right? So for this water, so gamma W is equal to 9.81 kilonewton per cubic meters. Okay, if you want in the form of the CGS system, so rho W is equal to 1 gram per cc over 1000 kg per cubic meters, right? So normally in the fluid mechanics we express in the form of the kg per cubic meters. So in the soil, whether we take the small quantity of the soil in the form of the grams as well as the dimension in centimeter, that's why we take the rho W in terms of 1 gram per cc or in CGS system. And if you want the internal system of standards, SS system, so gamma should be equal to rho g, 9.81 kilonewton per cubic meters, right? So the first term, the pore water pressure is positive. So if you insert the any standpipes, the standpipes like that, with the any piezometer or any pipes or any tensiometer like that, So due to the voids we have, the water will be raised to the up to the certain elevations of the static water level case, right? Now this static water level, right? So this is the, we want the pressure at this point X, and if you insert the piezometer or any standpipes, water will be raised to the certain elevation of water. That will be the head of waters. Okay. So with respect to the point, if it is rise, we call it as the positive, right? With respect to the point, if it is false, that we call as the your pore pressure is negative, right? So for this particular level, if it is lies above will be the positive and below will be the negative, right? That will call as the vacuum pressure. In case of the saturation of the soil under that saturation condition, it lies always above the given point. It always comes under the pore water pressure is always positive, right? If you want the stress at this point, the stress sigma, that should be is equal to, for this condition we have the soil pressure plus water pressure, but we want only water pressure as u should be is equal to, so gamma into height, right? So here gamma should be gamma w and height should be the head of water. We should always get it in the form of the positive, nothing but plus sign. Okay, it always get the positive pressures. If it is guess below, it should be the negative. Okay, then the volume of the water to volume of void should be equal to 1. As we know that the entire void is filled up with the water, the entire degree of saturation tends to unity. Therefore, volume of the void should be equal to the volume of the water. Therefore, this condition also get satisfied. Then we have the relative density is equal to 1, right? So the degree of saturation gives only the volumetric terms, right? Where the terms, the relative density gives only with respect to the relative density of the soil for a sandy or a gravelly soil. Therefore, we can't expect the relative density for a saturation of the soil samples. Okay, so for this condition, only the option 1 and 2 are correct, right? So in which of the statements are correct? Nothing but only 1 and 2, nothing but option A. Okay, the relative density can be defined with respect to their perfectly the natural void ratio, and we have certain limitations. What is their limiting equilibrium of the void ratio? If you take for a particular sphere or with a particular rounded particle, what should be the minimum void ratio and what should be the maximum void ratio? And we have the certain the soil property and we just compare it, right? So we have the ratio regarding the void ratio terms. So void ratio nothing but, so we have the soil particles and we have the certain voids and we just comparison with respect to the volumetric. Okay, so the volume of the voids is present with respect to their volume of the solids and we call it as the voids ratio, right? So what is the amount of the voids is present with respect to their solids? That will be the voids ratio, right? So here, based on their void ratio topic, will becomes under the relative density. This is applicable for only the sandy and the gravelly type of soils. Okay, so now we can observe this statement. Okay, so which of the following the statement? So each year, the blackened soil appreciably shrinks during a dry season and swell during a rainy season. This alternate cycle of shrinkage and swelling so causes the severe stresses in the structure supported directly by such soils. Okay, as we know that if you take the blackened soil and if you build on any structure, the masonry structure, as we know that during the summer season, you may get cracks, right? Both the foundation part and the wall part, we can expect a certain cracks. And during the rainy seasons, again, the soil get expand and also we can expect certain heave portions. So that in both the alternate cycles, we can expect the damage in the severe case. Then the blackened soil contains the predominantly clay mineral called a kaolite, which is responsible for the causing appreciable shrinkage and swelling, right? This is not correct because the blackened soil contains only the montmorillic, the clay type of minerals only, which causes the swelling and Therefore, it is not conditioned. It's not satisfied. Okay. If the soils contains about the montmorillonite, okay, so clay mineral only, which causes the soil to be expand and this the shrinkage during the alternate cycles. Right. The second one, the third one, the shrinkage and the swelling of the black-cotton soil are observed only up to a certain depth. So below the ground level. So below that level, there is a neither shrinking nor swelling. Okay. So that we called as the active zone. So nothing but, so we have the term we called as the active zone. The active zone. The active zone, nothing but the depth up to which only the soil gets shrinks and gets swells, right? So we have the black cotton soil and we have the certain, the typical sketch like that, and this will be the activeness of the expand or active heave, and maybe the get shrinkage and over the depth of the ground level. Okay, so the active is up to the during the certain depth only. After that, it remains constant. Okay, the zone up to which the majority proportion of the soil get here. So these portions we called as the active zone. Okay, therefore we can say the condition 1 and 3 will be satisfies, right? So you can observe from this graph. After that, so even if there is a water table is lies below that, I mean above that, so up to this zone only the soil get shrinks and get swells. After that, it remains same. So probably we should always getting the foundation design part. We should check what is the active zone depth. We have the John D. Bohr method to determine the active zone of the exploration, to find out that after that it remains same, right? So that for this condition we have the option 1 and option 3 is only the correct, right? Suppose if the option 2 they given about the instead of the kaolite, if they given about the montmorillonite, so we can say option 2 is also correct, right? So for this given the question, option 1 and 3 is only correct. Therefore, this regarding the option 4. Okay. So next you can observe the same statement. The partially saturated soil is an example of three-phase system. As we know that the partially saturated nothing but the sum of the voids is filled with either air as well as their water content. We call it the partially, right? Which have the three-phase system. As we know the three-phase nothing but we have the solid phase, then liquid, and it will be the then gaseous. Okay, so the solid part which will be completely the specific gravity of the coil depend upon their completely rotation is completely soil part. Then second will be the liquid part, which will be accompanied by the space will be the water, and gas will be remain with your air part, right? So always for a three-phase system, it consists of the three-phase for solid, liquid as well as the gases is called as the three-phase systems. Okay. Then if you take the second condition, the submerged density of a soil sample is equal to the saturated density divided by 1 plus water content is expressed as a fraction. It can't be true because the submerged density nothing but according to the principle of your Archimedes principle. Okay, so we have the ground level. Suppose if the water table is lies here, okay, so below that we have the soil sample. So here, okay, so here can observe it may experience for both vertical pressure in upward direction as well as the downward directions, right? So when you say the submerged density nothing but by the principle of Archimedes, right? So we should consider the effect of the total soil as well as the buoyant force, nothing but total soil pressure plus the water pressure. Okay, so downward pressure it always get the saturated pressure, And upward pressure, it always get the water pressure will be the we call as the buoyant pressures, right? The uplift water pressure will be the buoyant pressure. This submerged nothing but you should be take the effective nothing but you should take the difference. The difference nothing but the downward pressure minus upward pressures. Nothing but we can say the saturated minus buoyant force. It is regarding the your submerged only, just considering the effect, not this factor. The saturated density divided by 1 plus W, and it cannot be expressed as factor, it should be expressed in the form of the kg per cubic meters over gram per cc over Newton per meter cube over kilometer per meter, right? So that we can't use this, the second one. Now you can observe the third one. Void ratio of the soil sample is defined as the ratio of the volume of the voids to volume of the soil grains. As we know that in the soil particles for the given soil sample, so compared to the volume of the soil grains, what is the void ratio? Nothing but it is a ratio of volume of the voids divided by volume of the solids. We have to compare the voids with respect to their soil grains. Nothing but the option 1 and 3 are correct. Okay. So here we can say 1 and 3 will be the option B. Right. So submerged density always the difference between the saturated minus the buoyant, or we can say the pore water pressure or water density. Then void ratio should be defined as the ratio of volume of voids by volume of solids. Okay. So okay, I will stop at this stage. If you have any doubts, please ask. Okay. So here I so far covered about this soil according to the engineering point of view. Then how the weathering occurs, the physical and the chemical portions. Then how the physical, it may be the seasonal temperatures, maybe the splitting action of the splitting of the roots, then splitting action of the wedges, then flowing of water out of the abrasions. So then regarding the chemicals, we have the oxidation, hydration, carbonation, leaching, like that. So then the formation of the soil remain at the place of their origin, we call it as the residual. If it is moves from one place to another, we call it as the transported. And we have the transported agency. So nothing but the wind, water, then the still water, then the moving water, then the lake, or it may be the marine waters. Then the formation of the glaciers, and below that soil, we call it as the till, or it may be the drift. Then it may be the colluvial soils. During the landslides, the soil gets moves from one place to another. We call it as the colluvial soils, the talus soils, right? Then this all comes under their classification regarding the place of origin and their transporting agency. And we just observe the classifications of the soil based on their name. So what is the loam soils, humus soils, then loose soils. Again, what is meant by the sand, silt, and clay, like that. And then these are all comes under only the soil types. Okay, how the formation and what with the general formation, then classification of the soil. The next comes under when we have the phase system. It includes both solids, liquids, as well as the gas. They, based on their phase system, we have to use the certain relationship regarding the both volumetric terms. What is the amount of the water present with respect to the total volume of the soil? Then what of the air content, and what is the volume of content? Then corresponding to the right hand side, we have the gravimetric terms. What is the weight of the solids, weight of the water? Like that together we call it as the bulk soil. Then we have the combined both volume versus the water content and the weight of the soil. We can get the term will be the density. Okay. So next class we will start with the three-phase system. We have the certain the phase diagram. So in that we have the certain the numericals, the relations part. Then we have the definitions and certain numericals part. So once we finish that, we'll go to the soil classification system. Okay. So please ask if you have any doubts.